Hello everyone. Today we are going to discuss a generalized alternative interior angle theorem. We replace the transversal with a polygonal line. We choose the angles from left and the right side of the polygonal line alternatively. In this case, the alternative interior angle theorem still applies. Let's take a look. We start with a simple case. We have two parallel lines, L1 and L2, and a transversal. I define this angle to be angle 1, and this line to be angle 2. Then, by the alternative interior angle theorem, we know angle 1 is congruent to angle 2. Now, let's look at another case. Again, two parallel lines, L1 and L2. This time, my transversal is a polygonal line, like this. So we choose the first one, angle 1, on the left side of the transversal, and angle 2 on the other side, angle 3, back to the left side. Then what are the relations among these three angles? We introduce another parallel line called L3. Then angle 2 is separated into two parts. I define it to one is alpha, the other part is beta. So angle 2 is equal to just alpha plus beta. Okay, because of the parallel relation, L1 is parallel to L3, we know that angle 1 is congruent to alpha, alternative interior angles. For similar reason, L2 is parallel to L3, which implies angle 3 is congruent to beta. We sum up L1 plus L3 equals alpha plus beta, which is congruent to angle 2. So the first and the third angle sum up to the second one. Now let's look at the third case. Two parallel lines here, L1 and L2, and I have transversal polygonal like this. It's my angle 1, left side, angle 2, right side, angle 3, left side, and angle 4 here. This time, I introduce a parallel line through the vertex of the angle 3. The angle 3 is separated into two parts. The top part called the alpha, the lower part called beta. So angle 3 is alpha plus beta. From the second case we discussed here, you see 1, 2, alpha, these three angles. You see the parallel line is L3, 1, 2, alpha, similar to 1, 2, 3 here. So we have angle 1 plus n alpha equals angle 2, based on what we just discussed. At the same time, the lower part of angle 3 is beta. By alternative interior angle theorem, we see beta is congruent with angle 4. See, because L3 is parallel to L2. So this part with beta congruent to angle 4. We sum up these two equalities. That's angle 1 plus alpha plus beta equals angle 2 plus angle 4. However, we know this guy is angle 3. So we replace this with angle 3. So that's angle 1 plus angle 3 equals angle 2 plus angle 4. So the last case, we have like this. 1, 2, 3, 4 here, 5. You can verify angle 1 plus angle 3 plus angle 5 equals angle 2 plus angle 4. Okay, a similar extension from this case to this case by introducing a line here. Well, that's all I have today. Thank you for watching.